Example 5.6. Now, the random variable x, it is the age. Here's the age. Age, definitely age is a numerical. And now, it assumed it is a discrete. Because we had only 8 students, 8 ages. So we can think it is a discrete random variable. So here's a 19, 20, 21, and 27. How do you think? How many 19? It's 19 here. How many? 1, 2 out of 8. So now I can say we had 2 19, and the probability will be 2 out of 8. It is 1/4, 0.25. How about 20? 1, 2, 3. 3. 20s. Probability? 3 out of 8. How much is the probability as a decimals? 3 out of 8?
0.375.
Point 1.
0.375.
0.375. Thank you. And now 21. 21, how many? 1 and 2. 2 again. 2 out of 8. 0.25 again. And the last one. 27. We had only 127. 1 out of 8. I think it would be 0.125. So when you take the sum, the total of the frequencies will be 8. That was the number of possible outcomes in the sample space. And we add up the probabilities, always 100%. 1.000. 100%. It is the one of the properties for any kind of random variable. Sum up, it must be 100%. So this one is another random variable. See here, the random variable x denotes the age of students. It's good? Okay, I said random variable was a numerical. Can you remember what we did in chapter 3? It's not only chapter 2. In chapter 2, we made histogram, dot plot, stem and leaf with a numerical variable. Additionally, in chapter 3, we made the box plot. Yeah, we made the box plot with a numerical variable. And we got some statistics. Mean, median, mode, force center, standard deviation, variance, range, even quartiles. We took many statistics using numerical variable. See, random variable is numerical. Why not? We can take the mean. For what? Center, location. And also, we can take the standard deviation for the measure of the spread, the measure of the variation. So now, first, we are going to take the mean of the discrete random variable. So please look at this formula. Let me make bigger. You have to look at the formula carefully. First, we can take the multiplication. You know, the x here, it is not a multiplication. The x was the random variable. X was the notation for the random variable. So we take a value for the random variable times its probability. That means, let me go back to this example. Okay. That means for this one, take the value, random variable. What was the random variable in this example? The random variable x was the age. So take the age, 19, times, how much was the probability for 19? For the age 19? 0.25. Take the multiplication, 19 times 0.25. Separately, take another age, the second one, 20, times, how much was the probability for age 20? 0.375 times 0.375. So we can take multiplication for each. Next one. Next one, age was, no, I mean this one, 21 times 0.25. And the last one, age was 27 times probability 0.125. So we can take the multiplications for each value for the random variable times for each probability. And then what? Summation. Can you see the sigma here? Front, sigma. Sigma means take the sum. So why don't you take the multiplication, please? $19 times 0.25. How much will be? 19 times 0.25. 4.75. How about the next one? 7.50. And the next one? 5.25. And the next one? 3.375. And then take the sum, please. $4.75 add 7.50 add 5.25 add 3.375. How much would be the sum?
20.875.
20.875. It is the mean, average. Average of what? Age. You know, actually we had 219. We had 2 19s, 3 20s, 2 21s, and 1 27. Take the average, it will be 20.875. It is a mean. It is a mean. Just a second. In chapter 3, can you remember how did you get the mean in chapter 3? In chapter 3, just a second. Chapter 3. the mean, the notation was x bar. The mean was x bar, which was, we took the sum of the all values divided by the number of values in chapter 3. Okay, let me change a little bit. We had 2 19s, 3 20s, 2 21s, and 1 27. So let me list them. The ages. Which was 2 19s, 3 20s. How many 21s? 2 21s. And who was the oldest one? 27. We had 8 students. Let me take another mean in old way. Take the sum divided by 8. Okay? So let me try. 19 plus 19 plus 20 plus 20 plus 20 plus 21, 21, and the last one. The last one will be 27. Then what? Divided by how many? 8. Thank you. Can I rewrite this way? 19 over 8. No, not this way. Sorry, just a second. How about this one? How many 19s? 2 19s. 2 times 19. You know, multiplications is repeated addition. So 19 plus 19, it means 2 times 19s. Does it make sense? And the next one, 3 20s. By the multiplication, it will be 3 times 20. 2 times 21. And the last one is only 127. So I can write it's 1 times 27. How do you think? Is it good? Are they same? Not bad, right? Oops. So now, one more time, I can split each one. I mean, 2 times 19 over 8 plus 3 times 20 over 8 plus 2 times 21 over 8 plus 1 times 27 over 8. Can I do that? Because now the 8 is a common denominator. So sometimes we can merge them together with the same denominators, but sometimes we can split, like this way. Okay, just to keep it. How about this one then? 19 times 2 over 8. Can I rewrite the first one, the first term? You know, it is the multiplication and division. I can switch any way I want. I can rearrange them. You know, A times B will be same as the B times A. Yeah, why not? The first one. How about the second one? 20 times 3 out of 8. 21 times 2 out of 8. And the last one, 27 times 1 out of 8. So far, so good? Oops, it's not a good color. Have you ever seen this summation before? No, we did. Where? Just a second. Oh. I want to move them together. This one was this one. Please compare them. Let me see. Here was a 0.25, which was 1 over 4, 2 out of 8. Here's a 0.3, which was a 75. That was a 3 out of 8, because we had 3 20s. 0.25, the other 2 out of 8. 0.125, which was 1 out of 8. What we did? We took multiplications. We took multiplications here. And then what? We took the summation. We took the summation. Why don't you try? Why don't you try to this one? Please do this now. Definitely we are going to take 0.20, 875. What I want to say, before we took the mean, as usual, take the sum divided by 8. That is exactly same as this one. But what's the difference? Now we have a summarized table. You know, before we had a raw data. 19, 19, 20, 20, 20, 21, 21, and 27 in chapter 3. But now we had a random variable, and we summarized the random variable. How many 19s, how many 20s, how many 21s, 27. And we modified the formula. It is the modified formula one. But that is the same. But that is the same as before. Generally, we took the sum divided by n. We took the average. Yeah, that is this one. It's the same thing. Okay? So please understand the previous one, the usual way, and the new way, it's the same thing. To take the mean, average, for the center, for the location. Okay? So we just summarize. We just summarize and make the table. How about the second one? Now, why not? Not only the mean, but also we can take the standard deviation. To remember how many steps we applied before to take the standard deviation? We applied the 6 steps. 6 steps. Do you remember the 6 steps? long times ago. We applied the 6 steps. But let me remind you. In step number 1, we took the mean, x bar. Step 2, we took differences. Thank you. Actually, the difference was the distance from the mean, from the center. And then, step 3, we took square. And finally, we took the square root. But in step number 3, we took square. Step number 4, take the sum. Step 5, divided by n minus 1. I didn't explain to you why minus 1 yet, but divided by n minus 1 to take the average. Actually the variance. Now it is the variance, and the variance was on average. Summation over the sample size, but minus 1. Finally, step number 6, we took the square root to get what? Small s, sample standard deviation. Now, here's another formula to get the standard deviation of a discrete random variable. Yeah, it's ugly again. But look at this. Mu, that is the Greek letter. It is the Greek letter, is mu, which was the mean. Let me go back, go up. See? Can you see the mu here? The Greek letter is mu. It is the new notation for the mean. Before, in chapter 3, we used the x bar. But the Greek letter mu, it is the mean again, right? So let me go back. Go to the standard deviation here. So that is the step number 1. Take the mean. Same. We took the mean in step number 1, in chapter 3. Same. Step 2, we took the difference. Yes. Now we took the difference. Same. Step 2. What was step 3? In step 3, we took the square. Yes, we take the square. Can you see here? Square, step 3. What was step 4? It was take the sum. But now, yeah, we are going to take the sum. But before taking the sum, we multiply the probability, like as we did when we took the mean. Before take the sum, we multiply each probability. Now it is a chapter 4. It is a little bit different, right? And then chapter 5, take the sum. Finally, again, chapter 6, we take the square root. Before, we divided by n minus 1. But we don't have to do n minus 1. Do you know why? Please look at the probability. The probability was 2 out of 8. 2 19ths out of 8. 3 20s out of 8. 2 21s out of 8. 1 out of 8 for 27. We are going to multiply for each to get the mean or even to get the standard deviation. But before, we divided by 1 over n, which was 1 over 7. 8 minus 1, 7, 1 over 7. But now, we are doing 1 over 8, 1 over 8, 1 over 8, 1 over 8. The division the division by n minus 1, the probability has the role. Actually the multiplication times the probability. It is the procedures, the same as the division by n minus 1. But before, we divided by 7, not 8. But now, we are doing division by 8. That is only the difference. It's a little bit different. So, like as the mean, we can apply 6 steps again. But it's a little bit different. Step number 1, take the mean, same. Step number 2, take the difference, same. Step number 3, take the square, same. But now step 4 times the probability. 5 in chapter 5, not chapter 4, chapter 5, we took the sum. And finally, we take the square root. The same way. It's almost the same way. So now we can take the standard deviation by the new, almost the same 6 steps. I need a new page. Yeah, let's clean up. Okay, how many 19s? 2 out of 8. Okay, it's a 2 out of 8. How many 20s? 3 out of 8. 21. 2 out of 8. And the last one was a 27. Only one 27. So the summation will be the sum of the probabilities was 100%. Okay, step number 1. Now we have a new notation, mu, mean. How much was the mean? We took the multiplications, each, and then take the sum. How much was it? 20 point, I remember it was 20 point what? 875. Good, right? Second step. Now, to take the standard deviation. Take the difference again, right? So 19 minus 20.875. 20 minus 20.875. 21 minus 20.875. 27 minus 20.875. Please take the multiplications. How much would be 19 minus 20.875? Is a negative 1.875? Am I correct? Negative 1.875, right? It's negative 1.875. How about the second one? I think negative 0.875. And the next one, I think positive, what? 0.125, thank you. Next, last one. Positive 6.125. Same as before. Second step, we take the difference. What is the third one? Take the square. Please take the square. Remember, whenever we take the square, we can get positive score. So positive 1.875 square will be Say again?
3.5.
3.516. How about the negative 0.875 square?
0.76.
0.76 and 6. Okay. Next. 0.125 square.
0.016.
0.016. And the last one, it will be much bigger. 6.125 square.
37.516.
Say again, point.
37.516.
37 point. Please say again.
516.
5, 1, and 6. We took the square. That's good? Okay, now, step 4. It was a new one. Step 4 was the new one. What? Times each probability. 19 had 2 out of 8. 20, 3 out of 8. 21, 2 again, 2 out of 8. And 27, we had only 1. 1 out of 8. So please take the multiplication. How much will be the first one? Yeah, always to take the standard deviation is a longer calculation. So please take the first one. 3.516 times 2 out of 8. Please. Say again.
0.879.
0.879. Second one.
0.287.
0.287. And third one.
0.004.
0.004. And the last one. Last one.
It's 4.6.
4.68.
4.68. Are you wanting the third decimal?
Yeah, 3 decimals.
Okay, well it's 9 and there's a 5 next to it, so it would be 7. 4.7.
So 4 point just 7? 700? Okay. Now what? Step 5. Take the sum. How much will it be? The last one is, it says 4.7, but it's more decimals. It must be 4.689. When we take the sum, how much is the sum? With the 4.689, the last one, the summation will be 5.859. Finally, take the square root of it. Take the square root of 5.859 will be 2.421. Who is this? It is the standard deviation. Now we are going to use another Greek letter, sigma. It is a sigma. Good? So we can use another 6 steps. First, we take the average. Step number 2, take the difference. Take the square. But now, step 4 is a new step times the probability. Then take the sum. Finally, take the square root. Another 6 steps. It's almost the same.